You know, there's a secret language all around us. I mean, it's literally everywhere. It's written in the water you drink, the air you breathe. It's the language of the universe itself. And today, today we're going to learn how to read it.
So take a look at this. This is the formula for something called aluminum sulfate. Right now, it probably just looks like a crazy jumble of letters and numbers, right? Like some kind of secret code. But I promise you, by the time we're done here, you're going to be able to crack this thing like a pro.
So, you with me? Let's jump in and get started on this code-breaking journey.
Okay, our mission starts with the most basic tool a chemist has, the chemical formula. Every single substance, from the sugar in your coffee to the plastic in your phone, has its own unique formula. It's the key to understanding how pretty much everything is built.
The easiest way to think about a chemical formula, it's basically a recipe. Seriously. But instead of listing, cups of flour or teaspoons of salt, it lists the exact type and number of atoms you need to build one single molecule of something. It's the ultimate ingredient list for reality itself.
All right, so if a formula is a recipe, then what are the ingredients? Well, those are the elements. Let's take a look at how to spot them.
So an element is a pure substance. Think pure gold or pure oxygen. The very first and simplest rule for reading our chemical code is this. Just count the capital letters. That's it. Each capital letter you see stands for a different, unique element.
Let's try it out right now. Here's the formula for glucose. That's the sugar that gives us energy. Just take a quick look. Using that capital letter rule, how many different elements do you think are in this one molecule?
If you said 3, you nailed it. We've got C for carbon, H for hydrogen, and O for oxygen. See, you're already starting to read the language. It's not so bad, right?
Okay, so now we know how to find the types of atoms. But how many of each are there? That's where our next clue comes in, and it's called the subscript.
The subscript is that little number written just slightly below and to the right of an element symbol. Think sub, like in submarine. It's below the main line. This little number tells you exactly how many atoms of that particular element are packed into the molecule.
But what if you see an element with no number next to it? That's our invisible rule. If there's no subscript, it just means there's one atom. Chemists are all about efficiency, so the number 1 is always just implied. They never actually write it.
All right, we can now count all the atoms inside one molecule. But what if we have a whole bunch of them? That's how we scale up the recipe, and we do that with something called a coefficient. So the coefficient is that big number you see way out in front of the whole formula. If our subscript tells us the ingredients in the recipe, the coefficient tells us how many times we're making the entire dish. It applies to everything that comes after it.
And this is the key difference you gotta remember. Subscripts, the little numbers, tell you what's inside one single molecule. Coefficients, the big numbers out front, tell you how many total molecules you're dealing with. It's like the difference between knowing the ingredients for one cookie versus knowing you've got a whole batch of cookies. So how do we use it? It's really just simple multiplication. First, you figure out the atoms in one single molecule. So here, that's 2 hydrogens, 1 sulfur, remember that invisible one, and 4 oxygens. Got it? Then, you just multiply each of those counts by the big coefficient out front, which in this case is 2. Simple as that.
Okay, we've got elements, we've got subscripts, and we've got coefficients. There is just one final piece to our code-breaking puzzle: parentheses.
Every now and then, you'll see a group of atoms all bundled together inside parentheses. Just like in math class, this group acts like a single unit. And that little subscript outside the parentheses, it multiplies everything inside of them. It's basically the distributive property, but for atoms.
Let's walk through it. In just one molecule of this stuff, we have 2 aluminum atoms. Easy enough. Now for the parentheses. Inside, we have 1 sulfur and 4 oxygens. We just take both of those numbers and multiply them by that 3 on the outside. That gives us 3 sulfur atoms and, 12 oxygen atoms.
Okay, team, we have all the rules. We know about elements, subscripts, coefficients, and even parentheses. I think it's time. Let's go back to that monster from the beginning.
And here it is again. It doesn't look quite so scary now, does it? We're right back where we started, but this time, we know the rules of the game.
Let's put it all together piece by piece. For aluminum, we've got 2 atoms inside, times that big coefficient of 2 out front, for a total of 4. For sulfur, it's 1 atom inside, times 3 from the parentheses, times the coefficient of 2, giving us 6. And finally, oxygen.
4 atoms inside times 3 times that big 2, which equals 24.
So, what's the grand total? We just add them up. 4 plus 6 plus 24 gives us 34. 34 total atoms. The code is cracked.
And just like that, you did it. You took that really complex-looking chemical formula and you translated it. You've just taken your first and most important step into reading the fundamental language of the universe.
Think about it. From the salt on your table to the stars in the sky, every single thing has a chemical formula, a code just waiting to be read. Now that you have the key, the only question left is, what will you decipher next?